Alrighty, let's review what we learned in the last lesson with graphing systems. So first, let's graph the quadratic, the first equation. So I'm going to make a little table of values, and I'm going to go to my calculator, and I'm going to type in what I see there. Negative x squared plus 2x plus 7, enter. Then I'm going to go to the table. I'm going to try to go to the smallest value I could use, -3, -8. Then -2, -1. -1, 4. 0, 7. 1, 8. I have to make a second table. 2, 7, and now they're going to start to repeat. 3, 4, 5, -1, and 6, -8. All right, let's go ahead and graph this. -3, -8, 1, 2, 3, and down 8. 1, 2, 3, 4, 5, 6, 7, 8. Then -2, -1, -1, 4, 0, 7, 1, 8, 2, 7, 3, 4, 4, it should be 4, -1, and 5, -8. All right, let's go ahead and connect these points. Let's put some arrows on each end. And this is the graph of, this is the quadratic. Y equals -x squared plus 2x plus 7. All right, now we want to graph the linear function. You could use the table there and make a table of values, or you could do it remembering that this is our y-intercept. This is where we start at 2, and this is our slope. We go down 2 to the right 1, down 2 to the right 1. Hey, we cross right there. And now let's go up 2 to the left 1. Hey, up 2 to the left 1. Alrighty, and now let's connect these points. And this is the graph of y equals -2x plus 2. And the 2 points where it crosses right here, which is the point -1, 4. And it crosses right here, which that is the point 5, -8. So those are our two answers to the solution. -1, 4, and 5, -8. At those points, both equations are equal. All right, today we are going to learn how to do this algebraically using the substitution method. So let's just remember how many number of solutions we could have. When graphing a quadratic and a linear function, you could have 3 situations, which will determine the amount of solutions that we have. The first one, it could cross 2 times, kind of like in the do now. The second one, it only crosses once. Or lastly, it doesn't cross at all. All right, so let's throw back how to solve this system of equations algebraically. Because both of these are equal to y, we could just set these equal to each other. 4x plus 6 equals -5x minus 21. All right, to get rid of the 5x, we're going to add 5x to both sides. And that would give us 9x plus 6 equals -21. To get rid of the plus 6, I'm going to subtract 6 to both sides. And that gives me 9x equals -27. Divide by 9 on both sides. I get x equals -3. But just having my x is not good enough. I also need to find my y. So I'll use the first equation since it's positive numbers, the 4x plus 6 equation. Anywhere I see an x, I'm going to replace it with -3, since that's what I found out at x equals. 4 times -3 is -12, plus 6 is -6. Now using the second equation, let's check. Negative 5, x is negative 3 minus 21. And we need the answer to be negative 6, or there is a mistake. Let's see. Negative 5 times negative 3 minus 21. We are good. It works. Check. Alrighty. So let's look at how we're going to do this with substitution method to solve a linear equation and a quadratic equation. Basically, we're going to do the same thing where we set them equal to each other. We are then going to bring everything to one side, so we just have it equal to 0. And then we're going to use the different methods we learned for solving quadratics to fully solve. Alright, let's look at this one. Let's set them equal to each other. X squared minus 4x plus 4 equals x minus 2. We need to bring everything to one side, so I'm going to subtract the x, subtract the 1x, add the 2, add the 2. So you will have x squared minus 5x plus 6 equals y. Alright, first we're going to see if there's a GCF we could take out. The number in front of x squared is 1, which is good, so there's nothing we could take out. Alright, let's see if we could find out what adds and multiplies. Negative 2 and negative 3. And now let's set each of these equal to 0. X minus 2 equals 0. Add 2 to both sides, we get x equals 2. Now we're going to add 3 to both sides, and we get x is equals to 3. Alright, remember, you could check your answer by plugging in that 2 and 3 and make sure it works. And yeah. Oh, this is not how we word it. 1 second. We have 1 parentheses with a 2 and 1 parentheses with a 3. But we need to solve to find out what our y equals. So let's use the equation y equals x minus 2. So 2 minus 2 is 0. And then 3 minus 2 is 1. These are our two answers. Alright, sorry for that mix-up real quick. Alright, let's look at this next one. The only way we could... wait. We know a y equals right here, so we could replace it with y in the function. So, x squared plus 11x minus 12, and then put the rest of the problem in. Minus 30 equals 12x. Leave the x squared here, the plus 11x. Negative 12 minus 30 is negative 42 equals 12x. Now, to get rid of that 12x, we're going to subtract 12x from the 11x. And we get x squared minus 1x minus 42 is equal to 0. Now let's see if we could factor this. We could do a negative 7 and a positive 6. Which will end up giving us x equals 7 and x equals negative 6. Alright. Now we have to solve it. I'll use the one y minus 30 equals 12x is 7. So that'll be y minus 30 equals 12 times 7 is 84. And to get rid of the minus 30, we're going to add 30 on both sides. So we will get y equals 114. So that point would be 7, 114. And the next one, y minus 30 equals 12 times negative 6. So y minus 30 equals 12 times negative 6 is negative 72. Add 30 to both sides, and we get y equals negative 42. So our point would be negative 6 comma negative 42. All right, y. Let's check and make sure that these answers are correct. I'm just going to use the second equation, 7 squared plus 11 times 7 minus 12. Let me make sure the answer gets to 114. That's good. And let's check the next one. Negative 6 squared plus 11 times negative 6 minus 12. Make sure the answer is negative 42, which it is, so we are good. Alrighty. Now let's look at this application problem. Since opening day, attendance at Pool A has increased steadily, while attendance at Pool B first rose then fell. Equations modeling the daily attendance Y and the number of pools since opening X are shown below. Alright, and they want to know what day is the attendance the same and what was the attendance. Well, attendance is Y, and the amount of days is X. Okay, let's set these equal to each other. 28x plus 4 equals negative x squared plus 39x plus 64. I really don't like a negative x squared, but when I bring all of these over, it will end up being positive. Minus 39x, we have to do the opposite to bring it over. And this one is minusing 64. All right, so x squared, 28 minus 39 is negative 11x, and 4 minus 64 is negative 60. All right, now we need to find out what could work for this. 6 and 10, let's see, 3 and 20, 4 and 15. Let's do x minus 15 and x plus 4. That means on what days were the attendance the same? Well, first let's fix this. X equals 15 or x equals negative 4. Well, days can't be negative, so that's not going to work. So our answer for number 1 is at 15 days, attendance was equal. All right, and now to find out how much the attendance was, let's use the simpler equation. Y equals 28. X, I'm going to put 15 plus 4. 28 times 15 plus 4, we get 424. Attendance was 424. All right. I just want to double make sure that answer is right. Negative 424 squared plus 39. I'm supposed to put x. X is 15. All right. Negative 15 squared plus 39 times 15 plus 64. I'm going to say 64. Yes, that's correct. All right. Individual practice. You want to pause the video and try this one on your own. Again, these are both equal to x, so we could set them equal to each other. They're both equal to y, so we could set them equal to each other. All right, add the x squared to both sides. Subtract the 200x. And then subtract the 20. So we will get x squared minus 9x minus 52 equals 0. All right, let's see what can divide into 54. 6 and 9, that's not going to help me. 3 and 18, no good. I'm making mistakes. 119 minus 200 is -9. -32 minus 20 is -32. Okay. Numbers that multiply to 52 are 1 and 52, 2 and 26, 52 and 3 doesn't work, 52 and 4 doesn't, 4 and 13. Hey, those are the numbers, 4 and 13. So x minus 13 and x plus 4. Meaning that our answers would be x equals 13 and x equals -4. Our answer can't be -4 because we can't have negative number of days. And let's find out how many players there were using that easy y equation. Y equals 191 times 13 minus 32. And that gets us that the number of players there were was 2,551. I just want to check that with the other equation. Oh, I meant to type 20. -13 squared plus 200 times 13 minus 20. Oh, it's supposed to be plus 20. My bad. Yes, that gets the answer we had. Good job. All right, that wraps up our application word problems. And then remember, today we learned how to solve systems of equations when they're linear and quadratic using the substitution method.